Today we will talk about fractional distance. When we say fractional distance, what we mean is we're only going a fraction of the distance. A fraction, a small portion of it, a small part of the entire distance. So to introduce fractional distance, let's first take a look at the number line. So I have a number line up here, and there's a question up here. Point Q is 2/5 of the distance from A to B. So our job is to find where is point Q. From A to B. So let me make notes over here. A is at -20 and B is at -5. So to find fractional distance, it's a three-step process. First step, we want to figure out our total distance. How far apart are -5 and 20? So some will be able to count that in our heads, count down from -20 to -5. But as I mentioned with our distance, there is a way to calculate the distance between two numbers. I'm starting from A, going to B, so I take my second number, B, -5, minus the first number, -20. -5 minus -20 will get me a +15. Reason I am saying second number minus the first number is, first off, distance. From A to B, you should be able to see that's the same distance going from B to A backwards. You're still covering this part of the line. Reason I stress second number minus first number is, later down the year, you will encounter formulas where it is important that you pick what's your second x, what's your first x, and it has to stay that way. So I want you to get into the habit of always going with second minus the first. Okay. So there's my total distance, 15. Step 2 is I want to find the fractional distance. I'm looking at 2/5 of that distance. So what I want to do is take 2/5 off, that means multiply, 2/5 of that 15. 2/5 of 15 is 6. As a reminder, putting in fractions, alpha y equals, it's the first one. So I'm taking 2/5, 2/5, all the way to the right, multiply by 15. So as I mentioned, that's 6. 3/5 of my distance is 6. Now, is 6 my answer, which is here 0, so 6 is somewhere right here. Hopefully y'all can see that. No, I'm talking about numbers between A and B, and 6 is way out here. What this 6 tells me is, from my starting point, which is A, which is -20, I move 6 units over going to B. I'm going to the right. From A to B, that's moving to the right. And moving to the right in math, that's plus. So what you do is, step 3, your starting point, -20, plus how much we move, that 2/5 of the distance. -20 plus 6 equals -14. So 2/5 of the distance is at -14. And previously I stressed, distances are always positive. It doesn't make sense in context for me to say, I drove -14 miles. However, -14 here is not the distance. It's the point Q is at -14. So what that means in context is, I'm talking about that number right there on the number line, -14. So this number, don't make it positive. It's not a distance, it's a location, it's the spot, it's where we are on the number line. So there's your three-step process. for distance on a number line. What we may also see is distance on the XY grid. Now we have an X and the Y grid, and as I keep mentioning, we cannot count diagonally. So what we have to do when we're working with X and Y, let me zoom in a bit. When we're working with X and Y, is what we can do is draw a right triangle. And that right triangle will help us figure things out. Alright, now that I have my right triangle, what we can do next is let's look at the X distance, let's look at the X distance and the Y distance. On the X distance, from A to B, I move 1, 2, 3, 4, 5, 6, 7, 8. And from A to B, on the Y distance, I move 1, 2, 3, 4, 5, 6, 7, 8. Just note, in my example, it just so happens to be the X and the Y are both 8. They don't necessarily have to be the same all the time. Okay. So 8 and 8. Remember, that was step 1 from over here. Find the distance between those two numbers. Because we were on the graph, we could have counted them. The X distance moved 8, the Y distance moved 8. Step 2, let me work on the X first. My X distance is 8. The question says point P, which is what we're looking for, is 1/4 the distance from A to B. So I'm looking for 1/4 of that 8. So 1/4 times 8, which gives me 2. And let's do the same on the Y side. My distance is still 1/4 of that 8. Just so happens to be 2 as well. Again, they don't have to be the same all the time. They could be different. So what this tells me is, first let me ask, is 2, 2 my answer? Hopefully you said no. What this 2 and that 2 tells me is, from my starting point, which is point A up here, I move down 2, right 2. And there is my fractional distance. As an ordered pair on the graph, where is it on the graph? It's at 0 for the Y and -2 for the X. So -2, 0. The next question it asks is the ratio of AP to PB. So this right here is point P. Ratio, when we're talking about ratio, we're talking about parts. It's a fraction. So we said it's 1/4 the distance. If we're talking about 1/4, we're cutting something up into fourths. That means we have 4 parts. From A to P is 1/4. So it's 1 out of the 4 parts. So this is 1 out of the 4 parts. That means I traveled 1 out of the 4 parts of the way. How many parts do I have remaining? So I traveled 1. I have 1, 2, 3 remaining, 3 parts. That means my ratio is 1:3, 1:3. Alright. So what I'm going to show next is, what if my distance is again too large to count on the graph? Just like with the distance formula and the midpoint formula. What if they're too large for us to work with? So I'm going to work on this question next. It says point N, which what we're looking for, is 1/6 the distance from J to K. So let me go ahead and draw that right triangle just so we have a visual. But now, as I'm drawing my right triangle, you can start seeing that we can't count on that graph. The points aren't even nicely on the grid, and those are very large numbers. It's hard to count on this graph. So here's what we will do. So let me go ahead and take these points and write them on my separate sheet of paper. It said J was at 16, 84, and K was at 88, 18. So now we need to look at the fractional distance for both sides. Let me start with the x first, moving to the right. How far did J move to the right to get to K, from J to K? Here we go. I'm starting with the x side first. So I'm starting at J, I'm ending at K. How far apart are the two numbers? And again, when we say how far apart, that's in this example, we subtract the two numbers. So my second number is 18. I apologize, that's the wrong number. My second number is 88 for the x, 88 minus 16. 88 minus 16 gets me 72. Step 1. Find the distance between the two numbers. Step 2 is we take the fraction. The fraction in the question said 1/4 of the way. So I take 1/4 of that 72. Which, I'm just double checking my fractions here. Alright. Okay, I apologize again. It's not 1/4, it said 1/6. So this should be a 1/6. So 1/6 of 72 gives me 12. 12 is not my answer for x, it's how much I'm moving on the x. So let's take a look at the picture. From J to K, notice I am moving down and right. Because I'm moving to the right, that means on the x I am adding. I'm starting at 16, there's my starting point. Start at 16, and we are adding 12. That's our 1/6 of the way. 16 plus 12 gets me 28. So that means on the x value, we will end up at 28. Repeating the steps for the y. From J to K, I start at 84, I stopped at 18. So for the y, 18 minus 84 is negative 66. So they are negative 66 apart. But again, in context, we're talking about the distance here. So we don't really care about that negative sign. We just go ahead and say that they are 66 units apart. Now we take the fraction, which is 1/6 of the way. So 1/6 times 66, 1/6 of 66 is 11. 11 is not my answer. 11 tells me how much I move. I am starting at J, going down to K. Because I am going down, that's subtraction. On the Y, we start at 84. Starting at 84, going down, minus 11. To get me 73. That means on the Y, my answer is 73. And it's going to be hard to graph this simply because, again, the graph is not exactly scaled nicely. So 28 comma 73 looks like it's going to be somewhere over here. And they call this point n. Last part's the ratio. The ratio from Jn to Nk is, so let's talk about parts again. We're talking about 1/6 the distance. That means I'm dividing it into 6 parts. 1/6 of the way means 1 part out of the 6 goes up here. So I've gone 1 out of the 6 parts. How many do I have left to go? I have 5 left to go. I went 1 out of the 6, so I have 5 left to go. So my ratio is 1:5. Okay. Last thing I will show you for this question is this part B. Point R, which we don't know where it is on segment JK, so that the ratio of KR to RJ is 1:2. So R is somewhere in the middle, and now we're looking at the ratio from KR to RJ is 1:2. The point R is how much of the distance from K to J. So they gave us the ratio. 1 part is to 2 parts. So how many parts total do I have? 1 plus 2 gives me 3 parts total. From K to R is that 1 part. Because we're moving from K to J. R is somewhere on this line. K to R is 1 part. R to J is 2 parts. That means I am 1 out of the total 3. 1/3 the distance. Now that we have done 1/3 distance, we can go back and solve the rest of this problem. So going back from my previous one, we figured out on the x, down here is 72, and on the y, this side is 66. So let's take those 1/3 distances and figure out where we're supposed to land. Okay, what in part B again? On the x, I am taking 1/3 the distance of 72, and 1/3 of 72 gets me 24. This time note, we are going from K to J. We are going backwards now. From K, my x starts at 88 and going to the left to J. So 88 going to the left is minus 88 minus 24 gets me at 64. So my x ends up at 64. Same process for the y. I'm taking that 1/3 distance, 1/3 of 66, which is 22. Starting from K going up, I'm at 18. From K going up, I'm at 18. Going up means plus, so 18 plus 22 to get me 40. That means my y distance at 40. So on my graph, I see 40 for the y. 66 is right about here. And this is point, they called it letter R. Okay. So I showed you the 3-step process of finding that fractional distance. That 3-step process can be condensed into one equation. So now I'm ready to show you the equation for fractional distance. Equation for the fractional distance. Alright. And I will show you the x part first and the y part next. So let's start with the x. On the x side, let's look at our three-step process. Our first step is we subtracted. We found the distance between the x values. Second x minus first x. Okay? So what I'm going to do is call it our second x minus the first x. Find my find my distance between the two numbers. Our next step was, whatever that number turns out to be, we multiplied it by the fraction. So we're going to multiply it out here in front, the fraction. Our last step, there's my fractional distance part. I added it from my beginning point. The beginning point plus your fractional distance equals your ending point. So we're going to add it from x1. So what this means is your starting point plus this whole part, your fraction times the distance between your 2 points will get you the ordered pair for the x value. So y is very similar. Instead of x's, we just call it the y's. So there you have the three-step process for the x, which is the same three-step process for the y, condensed into one equation for each.